So what's a float?
I'm getting there.
Oh, well.
You're not very patient.
I'm not. I really need to learn patience.
Okay. So, anyways, byte, short, int, long. They all hold whole numbers, integers, positive and negative, just different size. Chars. These guys are unsigned whole numbers.
I crossed it off because you erased it, and now I have to write it again.
Like I said, I was giving you a sneak preview. So chars are unsigned whole numbers. Unsigned means that we don't hold positive and negative numbers. We just hold positive. These guys are 16-bit. They can hold the numbers in the range of 0 to 65,535.
Oh, that's the number of cells in the spreadsheet. Don't talk about me.
Okay, so 0 to 65,535. But now when we think of chars, we think of them as being characters, letters, numbers, or letters, the character version of a number, question marks, things like that. Those are chars. Well, computers like numbers. Any way you cut it, computers like numbers. So a char is actually an unsigned whole number, 0 to 65,535. And those guys map onto something called Unicode. So Unicode, 65,536 unique characters ranging from a majority of the world's languages. Unicode is called a character set, where numbers are mapped to characters. So again, computers like numbers. Humans, we want to be able to store the letter A and the letter B and the letter C. So internally, a char stores the Unicode value of A, and when we use it, it maps it to the actual character A. So Unicode is the lookup table, where it maps from a number to a character and from a character to a number. Other character tables that you may have heard of, another one is ASCII, American Standard Code for Information Interchange. So ASCII is 0 to 255. These are these are the 256 characters and symbols supporting American English languages, and you also have pictures of smiley faces and playing cards and crap like that. The first 256 characters of Unicode are equivalent to ASCII. So Unicode is a superset of ASCII. That make sense? Okay. What am I doing? Hold on. Relax. Yeah, I literally almost fell asleep there. I yawned so hard that I lost consciousness for a second. That ever happened to you?
No.
It is kind of shocking. I mean, I remember being a student a long time ago, obviously, but after a couple hour class, you get pretty exhausted, right? Mm-hmm. Nowhere near as much as teaching for 2 hours.
Really?
You wouldn't think, but just something about just sitting up here and babbling for that long. Well, it's just exhausting.
For you, you add more.
I'm an entertainer. I'm an entertainer.
Yes.
That's what you're looking for.
True. I just didn't want to make you sound like Cedric, then you might get conceited or something. So.
No, like I'm not already conceited.
But no, you put a lot more into it than others.
You gotta have fun, otherwise you just cry yourself to sleep.
Exactly.
No, jeez. But plus I have to act out while I'm thinking about the next thing I'm gonna say, right? It's in there somewhere. I just hope it comes up quick enough.
Gotcha.
Okay, so that's what a char is, and we'll explore each of these. Floats. These guys are signed floating point numbers.
What do you mean by floating point?
So 32 bits, followed by a decimal point, followed by 32 bits.
Oh. Gotcha.
So these are decimal point numbers. But the way they're represented is still two integers with a decimal point in the middle.
Oh.
Make sense?
Mm-hmm.
So the decimal point is actually an assumed decimal point. It splits it out. It holds a float in the same amount of space that it takes to hold a long. Doubles are signed floating point numbers, 64 bits, followed by decimal, followed by 64 bits. So float is kind of the integer version of decimal point numbers. Double is the long version of decimal point numbers. Floats hold big numbers. Doubles hold even bigger numbers. And finally, Booleans are unsigned 1-bit whole numbers.
So pretty much it just goes from top to bottom all over again.
0 or 1. So Booleans, we think of these guys as true or false. And we'll talk about that. But at the end of the day, as we go through these, byte short, int long, these are all integer types. Char, from a human perspective, these hold characters. But from a computer perspective, it's just another integer that does not know how to hold negative numbers. Floats, doubles, from human beings' perspective, these are decimal point numbers. From a computer's perspective, each one of these is two integers of different sizes. Boolean, from a human's perspective, this is trues and falses. Computer's perspective, it's a 0 or a 1. It actually probably stores them as bytes. Rather, it stores them as a single byte rather than a single bit. Go ahead.
I've noticed that in some systems they mark true as being like -1, I think.
I would think that that would never be true.
That's what I thought when I first saw it, but when you do it, like say in an Access database, you had a true false, you pull it up just in the table, it says -1 or 0, and then when you put it in Excel, it says true false.
And the -1 was false?
-1 was true. Hold on, wait. One of those two.
Historical definition was 0 is true, non-zero is false.
Gotcha.
That's the historical definition. So that would support kind of what you're saying.
Okay.
Is if it's a 0, it's true. Otherwise, it's false. If it's a 9, it's false. If it's a -300, it's false. It's anything other than 0 is false. Now, in practice, it's usually 0s and 1s. That goes way back. But anymore, we have them as values that we refer to as true and false. That under the hood are 0s and 1s stored as bytes. So, in any case, these are all of our primitive types. And again, remember that we're talking about variables. A variable is a name container for holding a value. When do we use these? When we need to use a value more than once. Syntax is type, name, value. So let's create some of these. Int a equals 5. Int b equals 7. So there's an example of where we defined a variable named a and set it equal to 5 all in one line. Here's another one where we defined a variable named b, and now b exists. Now we're going to use b and assign it a 7. Char c is equal to the letter a. Characters, chars are surrounded by single quotes. Double D, 3.14159, value of pi. We can say A is equal to B times 2. Stuff like that. All right.
So that just resets the value for A.
Yep, the single equal sign, this guy right here, is called the assignment operator. Assignment operator. Left operand is left type dash, yeah, is assigned value of right operand. So for example, B is equal to A assigns the current value of A to the variable named B. Sometimes I'll read this operator, the assignment operator, I'll say B gets A. B gets the value of A. All right? That's our assignment operator. Arithmetic operators. Plus, minus, times, divide. And these are all integer divisions when integers are used. Let me show you that. So for right now, system.out.println, that's how we print stuff to the screen. Just leave it at that for right now. All right, so we're going to print out A. Actually, let's do this. Then we'll print out A again. So right here, I'm defining a variable named A, set equal to 5. Then I'm printing out the value of A. So I'll print out a 5. Now notice that I don't redefine A. I don't say it's an integer again. I only do this once within something called a scope. And we'll talk about that quite a bit. Okay, so I defined it once, gave it a value, now I used it. Now I'm giving it a new value. I'm saying A is assigned a new value. The value it's assigned is whatever A currently is divided by 2. Then I'm going to print out A. So what will print out on this line? 5. What will print out on this line? 5 and 2 prints out.
Yeah.
Integer division. What is A? A is an int, correct?
Mm-hmm.
What kind of values do ints hold?
Whole number.
Whole numbers. Doesn't know how to hold a 0.5. So 2.5 gets truncated to a 2. Not rounded, truncated. The decimal point and everything after it gets cut off. Okay?
Can you print a float value system that out of print and ln and how we can put float in?
Yeah. Well, I mean, I could say this. Actually, let's make this double. Nobody uses floats anymore. So this will print out a double. if I truly want to get a divided by 2 as a double, I can do something called a typecast. A divided by 2. Actually, hold on. I still have to do it this way.
No, because the value.
Oh, I'm breaking it up here. I didn't need to do it that way. There you go. So this is turning A into a double, which basically says make this 5.0. 5.0 divided by 2 is 2.5. So what are you asking?
No, like I'm asking, like yeah, like instead of doing here at the system.out.print here, we can assign the value as float a equal to 5 at the top instead of integer. We can take the float and the value will be 2.5.
Oh yeah. So if I say this,
Yeah.
so if I make that a double up there, and then I say A is equal to A divided by 2, and then I print out A, I'll get 2.5. Because now I'm dealing with doubles, not integers.
Yeah.
Yep. This would be 2.5. So if I'm dealing with integers on either side, it will do integer math. Make sense? Okay. How many of you had, well, who knows, in some of these other countries, I think it was 3rd grade. How many of you had 3rd grade math? Remember long division?
Oh, I hated that.
Was that 3rd grade?
Actually, yes.
He doesn't remember.
Some of these smarter math countries, you might have had it like in kindergarten and stuff.
Right.
We did this kind of like long.
See, and as they start playing
I mean,
piano,
in Japan, these kids are being born anymore with abacuses in their hands. They're ready to go. Okay, so remember long division. So for instance, if I had 5 divided by 2 in long division, 2 goes into 5 2 times with a remainder of 1. Right? Okay. So we have an operator called the modulus operator, the mod operator. And it works this way. 5 divided by 2 is equal to 2. 5 mod 2 is equal to 1. Gives you the remainder.
Hold up. Repeat that, please.
See this up here?
Mm-hmm.
5 divided by 2 long division gives you 2 remainder 1.
Yes.
5 divided by 2 gives you the 2. 5 mod 2 gives you the 1.
Gotcha. Oh, yeah, that stupid mod. Okay.
So modulus is this is how we get the remainder of an integer division. So this says divide 5 by 2 and give us the remainder. Make sense? I'm going to give you a hint here. This might do you some good in some assignment we might have eventually. Modulus is extremely powerful. I know that might not make sense, but I promise you that 3rd grade math, long division, is one of the most powerful tools we have in computer science. It allows us to solve a lot of problems if we understand the nature of remainders. So for example, if I took any number, mod 15, what are my possible results? Or here, we'll ask it in the 3rd grade math way. We'll ask it in the 3rd grade math way. Pick your favorite giant number. Pick your favorite giant number. No, giant. You don't have to say it out loud. Everybody has a big number in their head.
45.
You don't have to say it, just in your head. See, now we're teaching comprehension. Okay, so everybody pick a big number in your head. All right, don't say it. I want to hear it. I want to hear this crap. Okay, whatever that number is, I don't care what it is. Now, if you took that number and you did long division, everybody does it. So write your number down. I want you to divide that number by 15 and calculate what the remainder is. Don't tell me. This is a magic trick.
I picked too big of a number.
This is a magic trick. So do long division with whatever number you picked, divide it by 15, and calculate the remainder. So whatever your number is whatever remainder something. Okay, everybody has their answer? Okay, so stand up if. I need 100% participation. Everybody promises?
Yes.
This is going to be a magic trick. I have to use my mind reading powers here. My hope is nobody stands up. Stand up if your remainder is 15 or greater. You did bad math. Yours is not 15 or greater.
No, because I picked up the 0.
Huh?
0.
You picked up a 0.
Your favorite number was 0. So 0 divided by 15. 15 goes into 0. 0 times with remainder 15.
Oh no, wait, but
Yeah.
you said pick a big
Yeah,
number.
I think that breaks math.
And you said pick a big number.
Well, regardless, you could say 0 is a big number, but
You're looking for Modulus 15. Is it 15?
yeah.
Okay.
Stand up if your number is 15 or greater. Your remainder is 15 or greater. Nobody's standing up. Why?
Because the remainder would be 0 to 14.
If you have a remainder of 15, that means your number went in one additional time.
Right.
So 3 remainder 15 is actually a 4 remainder 0. It is what it is. That make sense? So whenever you do long division, if you take any positive number and you mod it by a positive number n, your possible solutions are 0 to n minus 1. So in this case, since I told you to mod by 15, the possible answers would be 0 to 14. That make sense?
Yeah. Hold on,
Okay.
wait. So, all right, for example, I picked 50 as my big
Mhm.
number. And originally I had 3 remainder 5, but
Yep.
wouldn't it be 3 remainder of 3 because you have 3
15.
fives that
15
could go-
times 3 is what?
What? No, I was thinking about something else. What did you say?
You said that your answer was 3 remainder 5.
Right.
And you were questioning whether that's wrong?
Right, because I just put in my calculator and it was 3.3 repeating. But then I was thinking 5 goes into 15 3 times.
Yeah.
So would it be the 3 or the 5?
Okay. No, you're going backwards here. If you have 50, you take 50 divided by 15. 15 goes into 50 a whole number 3 times.
Right.
3 times 15 is 45.
Right.
50 minus 45 is 5. That's where you get your remainder of 5.
Gotcha. So I did have it right the first
Yep.
time. Okay.
Can you?
I should've
I
just
got the
took that
0
first.
to n minus 1 as the remainder. What was the other? What was the first?
The first spiel.
Yeah. calculation,
Okay.
Yeah.
So any positive number x modded by a positive number n. Here, modded by a positive number n will result in a remainder of 0 to n minus 1.
Can you flip back to that equal slide, please? Thank you.
All right. So arithmetic operators make sense?
They do.
All that crap? Okay. Now, let's talk about Boolean expressions. A Boolean expression is any expression that boils down to a single value of true or false. Any expression that boils down to a single value of true or false is a Boolean expression. All right, so let's talk about these. So we have things called Boolean operators. Boolean operators are less than, greater than, less than or equal to, greater than or equal to, equal to, not equal to. And none of these have spaces. So this is less than or equal to, no spaces between them. Greater than or equal to is two equal signs, no spaces. Not to be confused with the single equal sign assignment operator. Okay? So, for example, let's give us two integers. What will print out there?
It's less than 7.
A less than B? What's A? 5. What's B?
7.
Is B less than is 5 less than 7?
Yes.
So this will be true.
Correct. Interesting.
A less than or equal to? True.
False. It's gonna
5.
equal 5.
No, there's no sign.
No, 7. A is
Doesn't
gonna
work.
be 7.
5. 7. No, it doesn't work. Fine.
Which one is it? Thank you.
Change the value of B.
Yeah.
What is this? This is the assignment operator, right?
Yeah.
What does the assignment operator do? It assigns the right operand to the left operand. So after this whole thing boils down to the value of A. Because A just got assigned the value of 7. So if I were to print out A on the very next line,
It'd be 7.
we'll see that it's changed to 7.
Boom.
Don't do this. That would be considered bad programming practice. Okay? There are lots of things that you can do with programming syntax that you shouldn't do until you really know what you're doing. And even then, you're only doing it to show off. We'll see plenty of examples of these, but if you've ever, when you guys go and Google your assignments, and you see people doing things like A++ inside of print statements, or ++A instead of print statements, that kind of stuff, that's not good programming practice. We'll talk about what ++ and that stuff means later, but you know, if you know what you're doing, it should be very clear to you what the solution should be. There isn't a good reason not to just say A++ on its own line and then print out A inside the print statement.
But won't A++ in the print statement save you, you know,
It
code?
saves you a line of code and makes your code much more difficult to read by somebody who's an intermediate or weaker programmer.
That's true.
Okay, so we understand these guys? These are the arithmetic Boolean operators. Now we have the logical Boolean operators. Logical Boolean operators are and, or, I'll just show you those two. Here, I'll show you two additional ones, but I'm not going to really talk about them much.
Supposed to be.
So these are no spaces. So that's double ampersand, that's the and operator. Double vertical bar, that's the or operator. This is the bitwise and this is the bitwise or. And they're used for doing Boolean comparisons at the bit level on numbers. So if you had the binary number 101 and you ANDed that with the binary number 111, you would end up 1 and 1 is 1, 0 and 1 is 0, 1 and 1 is 1. This would be the result of a bitwise AND on those two numbers. Don't worry about that. Most of you will probably never use that. But it does exist. So for us, we have two different logical operators. That's the and the or. So A less than B and A not equal to 10. Let's get rid of this guy right here. So is 5 less than 7? Yes, that's true. Is 5 not equal to 10? That's true. So true and true is true. What if I change this to a 5? Now we're saying 5 less than 7? That's true. 5 not equal to 5? That's false. True and false is false. In order for an and to be true, both sides need to be true. So this whole thing will be false now. What if I change this to an or? Now it becomes a true statement. For true to be true, only one side needs to be true. All right, here's your trick question. What would the result of that be?
False. True. Because one of them is true. I'll make sure about A minus B. A minus than B.
Well,
Yeah, but hold on, look at this other side.
true, because you
What am I doing here?
You can't divide a number by 0.
Infinite is greater than
The memories.
No, it's gonna be
One
no.
of them true, one false. The result will be true. Because it's all.
Well, hold on, I'm dividing by 0. This is illegal math.
Right. You can't do it.
You can't divide by 0. There's at least a 50% chance my MacBook Air will explode.
Let's try it. Run it. Run it.
The output of this is true. The question is why?
Because that one side.
Hold on, I'm gonna prove something. I'm gonna prove something to you.
Because of the extra parentheses.
There's our divide by 0 error.
It gives me infinity.
It gives you infinity.
So why did I get a true there if we just proved that this can't work?
Because he ignored for the second thing. He makes sure about the first one's true.
This is the OR operator. Very important lesson here. This is the OR operator. In order for an OR to be true, only one element needs to be true. Java's smart. Once it sees that this part's true, it's not even going to waste its time looking at the rest. It didn't even do that math.
Interesting.
So if you do an and there, do you get the error or do you get a false?
Oh, no, you get the error.
Okay. That's what I didn't know.
Because we did the math.
Yeah.
You know, with the OR there, as soon as we ran into our first true, we're not even going to look at the rest of the expression.
Yeah.
We don't have to.
Sure.
It doesn't matter if everything else down the line is false. I'm going to ultimately boil down to true because this is an OR. This is an OR. But if I'm dealing with an AND, as soon as I hit a false, it will stop. So here's the, if I switch that around like that, we won't get the error. We'll just get a false. Because since this first part was false, it didn't waste its time checking anymore. Since it's an AND, we find one false, we're done. Does that make sense?
Yeah.
Okay. Important concept. Because let's just say you were one of those programmers that was trying to do something sneaky or something like that, like A gets the value 5 greater than 4 or something like that. So 5 greater than 7?
No.
Nope. Is 5 greater than 4? Yes. So will this be true? And then what will A be?
5.
5. True and 5. Switch this around. A less than B. Is that true?
Yes.
Yep. What's A going to be?
5.
Oh, hold on.
Six.
It's a bad example. Bad example. So 6 less than 7?
Yes.
Yes. So this is true. Even though I'm assigning A to 5 here, it won't do that. I won't get to the second half. It'll print out 6.
Right.
That make sense?
Yep.
Okay, so it's important to understand how ANDs and ORs work and what Java executes and does not execute. And when I say Java, you can replace that with C#, you can replace that with C++, you can replace that with C. All those languages work the same way. Most programming languages work this way. Visual Basic included. All right. Questions about that? We have one more operator, the NOT operator. The NOT operator flips a true to a false and flips a false to a true. So not true is equal to false. Not false is equal to true.
So when you're programming in Java, you just put not true like that, and then it automatically bless you. Oh, gotcha.
Is 6 less than 7? That's true, right? But this will print out false. Because I flipped it using the not.
Okay, gotcha.
So not A less than B is the same thing as saying A greater than or equal to B. They're equivalent statements.
Do you
Okay.
still need the extra parentheses.
No, it's just I just left it in there. Make sense? Okay. So we think we have a pretty good feel for Boolean expressions. What's a Boolean expression again?
An assignment that dribbles down to true or false.
Any expression that boils down to a single value of true or false. All right, let's see. Is that a Boolean expression?
Yes.
Is that a Boolean expression?
No.
Is that a Boolean expression?
No.
Is that a Boolean expression?
Nope. Yes.
I'm not done yet. Right now it's illegal syntax. That a Boolean expression? Is that a Boolean expression?
Yep. Because it's just
No.
going to print out
It's
true.
syntax, I mean,
No.
no.
Yes, true.
I thought you guys said you understood this.
Run it.
Yes, yes.
Run
One
it.
says
True.
Run it.
No.
Okay, who thinks it is a Boolean expression?
No.
Two people thinks it is. Three
Yep.
think it is a Boolean expression. Who thinks it's not a Boolean expression? Why not?
Yeah, because we are not
no
assembling
operation.
operators. So if there is no operator, it's not Boolean expression.
What's a Boolean expression again?
We need to assign the operator.
No, hold on, hold on.
Increase the character. So we-
What's a Boolean expression? What's the definition of a Boolean expression?
It's like, yeah, it's like true, false, or comparing
Go back to the slide.
What's the
true or false.
any expression boils down to true or false?
Keyword any.
Did I forget to must use operator?
No.
Must us operator? Did I forget that part?
Yeah.
No,
The sad,
I didn't.
the sad part is his face was so serious.
A Boolean expression is any expression that boils down to a single value of true or false. Any expression.
Keyword.
There's no requirement that we must use operators to do it.
So us three people were correct.
If this keyword, that's meaning
What's this?
Sure.
is this keyword in Java?
Yeah, it's purple.
Okay.
And even if it wasn't, is that a single? Does that word match this word?
Yes.
What is why?
All right. So this is a Boolean expression. It's an expression that boils down to a single value of true or false.
And it's going to be true.
It's true.
But true is a keyword.
True it's a literal. So yes, it's a keyword. It's a keyword that means true.
Yeah. So,
It's the same thing as saying 5.
So any
5 is a literal.
yeah, can we assign the keywords as output? So
Well, I mean, I can say Boolean C is equal to true, and I can say C here.
yeah, and then
Well, it was correct before.
so true is a keyword, so we can't assign the keyword as a solution.
We just did. See my output, it works. You see this?
Yeah, like can we assign C or C++?
Yeah.
The same logic.
Mhm.
It will work.
C++ definitely. C# definitely. C yes, it would. All of them. Same thing with Objective-C. Objective-C doesn't use trues and falses. Actually, it will use true and false, but its preferred method is yes and no. Yes is true, no is false. But understand, this is just a literal. That's the same thing as printing out 5 or 6 or 7. True is a value. It's a literal value. It's a hard-coded value built into the language. Underneath the hood, that's probably the byte 1. Something like that. All right, so Boolean, go ahead.
Is it same thing like printing hello world?
Well, to an extent, yes, but printing out hello world, this guy's a string, so I wouldn't call this a literal. This is actually a string representation of an object, but for our purposes right now, we could say, yeah, it's the same thing. It doesn't break anything I'm about to show you. All right, questions on this? Do you understand Boolean expressions pretty well? Okay, so what do we use Boolean expressions for?
Or anything that you want to represent as true or false.
Well, now we got to get back to our how do we solve problems? Human beings solve problems by
Storing it.
remembering things, asking questions, and repetition. Well, we've already dealt with remembering things through variables, right? Now we need to ask questions. So we have something called a conditional, also known as if statements. Syntax for an if statement is the word if, followed by an opening parenthesis, followed by a Boolean expression, followed by a closing parenthesis, followed by an opening curly brace, the body of code, followed by a closing curly brace.
So no then.
No then in this.
Okay.
Optionally, you can have an else,
Bless you.
followed by an opening curly brace, followed by a body, followed by a closing curly brace. The square brackets there represent optionally. So it's not actually part of the syntax. I can remove it, but just remember the else is not required. This make sense? So let's see this in action. If A is less than 10, system.out.println woot.
You forgot the second root.
I didn't want a second woot. I'm not that excited about being less than 10. All right, so what's this program gonna output? Woot. Now what's my program gonna output?
It's still gonna say root. It's still gonna say. Oh no, it won't. My bad. I didn't see the if statement.
So what will it output?
Nothing.
Nothing. Not a false. This is asking a question. I'm saying if A is less than 10, if that's a true statement, do whatever's inside these opening and closing curly braces. If this is a false statement, don't. Just move on with life.
We need else.
Optionally, I could have put an else in here.
So can you do else if or no?
Well, the short answer is yes, but there isn't an else if structure. It's just an if instead of an else.
Gotcha. Thanks.
All right, so if A is less than 10, print out woot. Otherwise, print out VB sucks.
I think you are an unequal opportunity offender.
No, I'm definitely an equal opportunity offender.
I don't know.
I'm pretty sure.
You haven't even, after like the first 5 minutes of class, you haven't even talked about cricket again.
Well, not cricket, but didn't I say something? Oh, I made fun of the efficiency of India.
That's true.
All my cricket peeps were late to class.
That's true. They all came in as a cricket
They were
game.
too busy playing cricket in the fog. When I pulled into campus at like, I don't know, 5:45 or something, there was a bunch of people out on the outside of the parking lot playing ultimate frisbee in the dark and fog. I mean, that's the kind of dedication I expect from cricket players, not from ultimate frisbee players.
Actually, I saw them out there playing earlier today in the fog. It was a little more light.
Yeah. All right, so this one prints out VB sucks. If I change it back to 6, it prints out woot. What does this print out?
VB sucks.
VB sucks. What if I change it back to 6?
Woot and VB sucks.
Woot and VB sucks. Because this is not in an else. This happens regardless. Okay, so this if statement is just, this is a statement and this is another statement. They're completely unrelated to each other as it's written. Make sense? Now, what prints out now?
Both the woot and VB sucks.
Fall.
And then a true. Why didn't it print out true?
Why would it print out true?
Because A is less than 10.
Where am I displaying true?
No way. Never mind.
What prints out here?
Fall.
Both.
What prints out here?
Nothing.
Nothing.
What prints out here?
Fall. VB
Fall.
sucks. Fall.
Fall.
No.
VB sucks.
It prints out both.
Nothing. VB
No.
sucks.
Wait.
This prints out VB sucks.
Why just VB sucks?
This is another thing I harp on about bad programmers. Always, 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 always use curly braces. Technically, you do not need curly braces with an if statement if you have one statement following it. But here's the trick. Your one statement connected to that if statement is that guy. This other guy just happens to be indented similarly. He has nothing to do with that if statement. He prints out regardless of the output of that if statement. It is never, ever wrong to put curly braces explicitly around the body of what is part of your if statement. And again, when you Google your answers off to your homework assignments, you'll see plenty of people who think they're being smartasses omitting the curly braces. It makes our code difficult to read, and it's error prone. Because it would be very easy to accidentally indent two things and think they're actually part of the if statement and get strange output, all because you decided to save yourself 2 lines of code by not putting curly braces in. That make sense? Mm-hmm. Some books will also do things like this for your curly braces. There's nothing wrong with that. Books adopted this to save space, because when you're with printing, every line does in fact count. I would encourage you not to put them like that. I think you should put your curly braces like that, where you can see the beginning and you can see the end stacked on top of each other. That would be my recommendation. Java doesn't care. According to Java, you could put your whole program on one line. Java's perfectly happy with it. Doesn't care. Okay.
Does it do that in Word too?
Hmm.
Does it do that in Word too? I mean,
BB?
no, I don't, PCs.
Oh, yeah.
Okay.
Yeah, what I just did is all the code was displayed like that. I highlighted that line. Then you right-click on it, go to Source, and one of the options is to Format. And it will pull it back out to something readable. Similarly, if I do something like this, and I want to indent my code, which I also encourage you all to take time doing. Eclipse tries to help you do it, but go to Source, Correct Indentation, and it'll indent it for you. So sometimes if you forget to put curly braces, you're bringing things into a if statement, you might want to have it re-indent for you to kind of fix your formatting. But something that you'll want to be careful of when you're writing this stuff is not having everything left justified and all that crap. It'll make your code hard to debug and cause you a lot of headaches. Take the extra time. Eclipse is going to do it for you. I mean, if I press enter right here, it kicks me in. So it does some indenting for me anyways. But take your time, make your code look formatted, make it look structured, and you'll have an easier time debugging it. Make sense? All right, so do we understand if statements? Okay. So the last thing we try to simulate is repetition. And we do this through something called loops. We have three kinds of loops. We have a for loop, a while loop, and a do while loop. There technically is a fourth loop that we'll look at eventually, but these are your three common loops. A for loop is a pre-check loop. We'll talk about what that means. A while loop is a pre-check loop, and a do while loop is a post-check loop. For loops. Here's the syntax. Actually, I'm going to start with while loops. While loops. Syntax. The word while, opening parenthesis. Boolean expression. Closing parenthesis. Opening curly brace, body, closing curly brace.
Weren't you supposed to bring out the evil cats?
Hmm?
Weren't you supposed to bring out the evil cats?
Bring out the evil cats.
Yeah, you said you were going to show a picture of your evil cats.
Yeah, remind me at the end. I'll do it.
Gotcha.
Okay, so while, Boolean expression. What's a Boolean expression?
It is a
True or
value, any value that boils down to true.
Any expression boils down to a single value of true or false. So while some Boolean expression is true, execute the body of this loop.
Pre-check.
Okay? So I create a variable named A. Start A off at 5. Now, while loops are pre-check loops, which means we ask the question before we execute the body of the loop even once. So while loops, a while loop being a pre-check loop, will have its body execute 0 or more times. Is A less than 10? Yes, that's a true statement. So we'll come inside the while loop and execute. So this will print out a what?
A.
Print out a 5. Prints out the value stored inside the variable named A. It would print out an A if I said that. Make sense? Difference?
Question.
All right.
Does it increment up one?
Do you see it incrementing?
No, but I didn't know if it did it on its own or something.
Yep.
Wow.
So this will print out a 5. Then we spin back up. What's the current value of A? 5. 5 less than 10?
Yep.
Print out a 5. 5 less than 10? Print out a 5. Let's just keep spinning. This is an infinite loop. So this will just print out A or print out 5 for a while.
Yeah, you're gonna break your system. How much?
So realistically, we would want to change A inside of our loop. Maybe say A is equal to A plus 1. I hit the little red box right here.
It's cute.
All right, so now A is 5. Is 5 less than 10?
Yes.
Yep, print out 5. We're assigning to the value A, to the variable A, the current value A, which is 5, plus 1, which is 6. So now A is 6. 6 less than 10?
Yep.
Yep, print out 6. 7 less than 10?
Yep.
Print out 7. 8?
Yep.
So there's my 5, 6, 7, 8, 9. The last time through, what's going to print out here?
9.
I hear a 10, I hear a 9.
It's gonna do a pre-check. So it's gonna be
10.
9. Why 10?
Well, here's why. Is 9 less than 10?
Yes.
Yes.
So
Print out a 9. 9 becomes 10. Is 10 less than 10?
no.
Nope. Print out the current value of A, which is 10.
Gotcha.
Make sense?
Yeah.
Okay, now let me show you the equivalent for loop to this. And we'll have the for loop spin on a variable called B. Okay, so this loop down here and this loop up here have equivalent outputs. A for loop is also a pre-check loop. A for loop is actually quite a bit like a while loop, except what it's done is it's brought in some of the outlying parts of a while loop into the header of the for loop. For instance, before a while loop up here, we defined a variable and gave it an initial value. We did that one time. In a for loop, that statement is right here. That happens one time, and it happens first.
So you do the variable constraint and then the increment. If there's an increment.
Yep. So this line and this line are the same as each other. Then we have our Boolean expression, and then we change our value here. just like we're changing our value here at the end. And all these things happen in the same order as it happened in the while loop. So when we come into a for loop, this happens first and only once. Then, it's a pre-check loop. We ask the question. If it's true, we execute the body of the loop. Then, we do whatever this says to do. Then, we ask the question. If it's true, execute the body of the loop. Then, do whatever this says to do. Then, ask the question. If this is false, we end. We keep going on. So this should print out. This should print out the same thing as we printed out before, 5 through 9. So we should get 5 through 9, then 5 through 9. Make sense?
Yep.
Now, technically, and you will likely not do this very often, but technically, you can define more than one variable here. So you can define more than one variable here. You can also change more than one value here.
But you can't add more than one Boolean expression.
Correct. Well, a Boolean expression is a singleton. It could be a really complex looking one. But yeah, you cannot have more than one because it wouldn't make sense.
Oh, yeah, that's true.
So I'm going to print out B and C each time through here. And you see C is changing at the same time as B is going up. So technically, what is that doing? That is simulating this. So this more complex looking thing down here is doing the same thing as we're doing up here. Make sense? But while loops and for loops are both pre-check loops, so they both execute 0 or more times. And there is not a guarantee that we will execute the body of the loop even once. And this is going to be very rare that you would see somebody use a for loop and have more than one thing in here. It does happen, but rare. Just showing you it's possible. All right? Questions about?
Why do we need them if they have the same function?
Why do we need a for loop?
4 and 5.
We'll talk about it, but let me give you an example. It's funny you should ask.
Funny. That's good.
It is. All right.
Can we define the same variable twice?
Sort of. That's going to be part of this funny.
That's another one. Can we use double?
Yeah. Well, here, let me show you one comic at a time. All right. So start A off at 5. As long as A is less than 10, print out A. Over and over and over again, then we print out A again, right?
Right.
Okay, so this should print out 5 through 10. Seen it happen, right? There's my 5 through 10. Now, what will this print out? 5 through 9? What will this print out?
9.
And
The last value
Well-
is 9. 10. Sorry, 10.
Mm-hmm.
9.
9? Why not 10? The while loop printed out 10.
Yeah, first we need to check the conditions and then it will print the value. So
No, it add the value, then it check the condition.
Or add one.
10 took away from the loop.
So
Well, what's the difference? I mean, this is a for loop, and a while loop is a pre-check loop. A for loop is a pre-check loop. A start off as 5. Is 5 less than 10? Yep.
Yep.
Print out 5. 5 becomes 6. 6 less than 10?
Yep.
Print out 6. 7 less than 10?
Yep.
8 less than 10?
Yep.
9 less than 10?
Yeah.
Print out 9. 9 becomes 10. 10 less than 10?
No.
No,
Nope.
it's not adding. It's 10.
10. That's what you think it's going to be? Well, it's going to yell at me. It's not even going to let me run this stupid thing.
Yo, it's
Why?
not leave the braces.
Well, they're there.
Why would-
All my curly braces are in the right place.
That's weird.
Variable scope. This is where a variable is accessible. I defined this variable name A as part of my for loop. So when I defined that, a miniature variable environment was created that lived and died right there.
That makes sense.
So when I get out here, it's never heard of A. Doesn't like this either. Why not?
Because it has two values. One
I already have an A.
Yeah.
Yeah.
I'm trying to redefine an A right here.
Yeah.
So in this case, we have a variable named A, and this A lives and dies with this for loop. So when I exit this for loop, it's never heard of A.
No. Yeah.
I could define A now.
But not the same A.
It's a new A. This A died. When that for loop ended, this version of A disappeared. It no longer exists.
Yeah, it still lived when you put it before it. So then that made it have two variables or reassigned.
What if I did this?
That should work. Because A still lives outside of for
So I forced the issue. I actually defined A outside of the loop. I didn't even give it a value. Defined it. I could have given it a value. Here,
but what would the value end up being?
here, we'll give it a value. A is 500. Then I run this loop. A becomes 5. Prints out 5, 6, 7, 8, 9. Exit the loop. What will A be?
500.
500.
It will be 10. Just like we all thought.
Oh yeah, because it's reassigned.
A is only 500 for a split second. Because we immediately give it a brand new value right here. Overwriting the 500. It's not like we lose track of it. All I did by defining my A out here is I shifted where the scope of A is. Instead of A being a local variable to this for loop, it's now a local variable to this method. It can be used anywhere inside of that method, including inside the for loop. Okay, so if I just follow it through, A is 500. Great. Now I'm going to change the value of an existing variable named A to 5. Notice I didn't say int before it. A is already defined. I've already defined a variable named A of type int. I'm just using it here. I'm using it in conjunction with the assignment operator. It's saying reassign A to the value 5. Or change the value of A to 5. So now the 500's been overwritten with a 5. Then I go through the motions, do my 5 through 9 stuff. 9 becomes 10. Is 10 less than 10? No. Fall past the loop. Print out the current value of A. It knows about it because A was defined in this scope. But it's no longer value 500. It's now been altered inside this loop. Make sense? So that's why we get the 5 through 10. Okay? So now you ask the question, if they're the same, why might we use an integer or a for loop versus a while loop? Would you agree that most of the time variables that are named things like A and B and I and J and K are probably throwaway variables that we're only using for a very temporary amount of time?
Yes.
If they were a meaningful variable, we'd probably give them better variable names, like number of years or something like that, right? A meaningful variable. But these we're just using for quick counting problems. Since it's a throwaway variable, for loops, which generally speaking lend themselves to counting problems. I'll rehash that in a second. But for loops, since they create their own little environment, allow us to use the same little throwaway variables over and over again. So typically, the common throwaway variables you'll see is like for int I equals 5, I is less than 10, I equals I plus 1. So I tends to be a common counting variable. J and K, those three are the common counting variables. We already saw you can use A. I'm just saying when you do your Google searches, you'll see a lot of I, J's, and K's. But I can create a second for loop right here that defines I again and does the same crap a second time. This is I. This is a second I. And I'm defining them both times. I'm saying this guy's an int name I, this guy's an int name I. And they don't conflict with each other because by the time I get here, this guy's dead. He no longer exists because he died when this for loop ended.
And then you resurrect them
Well, I'm not even resurrecting him. I'm building a brand new one, a better one.
with the same variable.
Same variable name and it happens to be the same values. But it's not the same one. I'm not bringing back to life an old one. I'm creating a brand new one. So this does the exact same logic twice. So one of the advantages of a for loop is it allows us to reuse throwaway variables easily. Otherwise, you have to come up with all these extra variable names or remember what you've defined and haven't defined and all this other crap. Okay. So a while loop lends itself to problems where we do not know how many times the loop must repeat. For example, press any key to continue. So if you get a prompt on your screen that says press any key to continue, how long will it be until somebody presses a key? Might be immediately, might be 10 seconds, might be 10 minutes, might be never. So that would be an example where we're going to keep asking the question, do they press a key yet? No. Did they press a key yet? No. Did they press a key yet? No. Over and over and over again until something finally occurs. So that would be the type of problem a while loop would lend itself to. Although we've already seen we could do counting problems with them, right? Maybe a blanket statement I'd say is that any problem that requires looping, you could solve using any of the three loops in conjunction with some if statements to make it work out right.
Or if any line inputs coming from the user.
If any what?
Any inputs that come from the user,
What about it?
we can use while. It's good idea to use while instead of for loop.
I don't think that's necessarily true. Because here, let me do the for loop slide, and then you'll see what I mean. So for loops you've already seen the syntax. Lends itself to counting type problems. So if we did prompt the user to enter a number 1, let's say 1 through 10, and then we were going to do something that number of times. It's true that we don't necessarily know what that number is, but we do know that it is a number. Therefore, we know how many times we're going to have to spin. We're going to have to spin that number of times. See what I'm saying? So even though we're getting our data from the user, we still know how many times we need to spin. It's stored in a variable. Maybe the variable's called num times. So how many times is this loop going to go? It's going to go num times, number of times. Num times might be 5, num times might be 13, num times might be 1,000. But we know that num times holds the number of times this loop needs to spin. All right, so for loops lend themselves to counting type problems. Example, count from 1 to 100, something like that. Do while loop. This guy is a post check loop. It works a little differently than the other ones. The body executes at least one time. Syntax is do, opening curly brace, body, closing curly brace, opening parenthesis, Boolean expression, closing parenthesis, semicolon. I'll show you this in practice. I would probably kick it down there like that. So here's a for loop, starts I off at 5, keeps going as long as it's less than 10, so this will print out 5 through 9. Here's a do loop. We create a variable named I, start off at 5, print out 5, 5 becomes 6, is 6 less than 10? Yep, spin back up, print out 7, 7 becomes 8. I'm sorry, print out 6, 6 becomes 7, is 7 less than 10? Yep, print out 7, 7 becomes 8, 8 less than 10, so on and so forth. 9, 9 less than 10, yep, print out 9, 10, 10 less than 10? Nope. So the output of this for loop and this do identical. 5 through 9, 5 through 9. But now let's look at an example when they're not identical. Start I off at 5,000. Start I off at 5,000. What's the output of this for loop? Nothing. What's the output of this do while loop?
1 times
Nothing.
5,000.
5,000.
Oh, yeah.
executes at least once because it's a post check loop. We don't actually ask the question until we get to the bottom. So I is 5,000, print out 5,000. 5,000 becomes 5,001. Is 5,001 less than 10? Nope. Done. So this will print out a 5,000. Make sense? Okay. So, questions about any of that stuff? Let's check to make sure I've given you everything that you need for your homework. So write a Java program that counts the number of numbers between 1 and 1 million that are evenly divisible by 9, 13, 27, or 81. Your program should display the total count to the screen. Oh, that's a good one. Yep, you know everything you need for that one.
Wait, so do you want to see remainders or it has to be...
Write a Java program that counts the number of numbers
Oh, okay.
between 1 and 1 million that are evenly divisible by any of these 4 numbers.
Oh, so we don't have to do all of them, just any one of them.
I want to know the number of numbers that's evenly divisible by any of those.
Okay.
I would probably take a few minutes and read the question closely, and it'll make sense. And then you have another report. Well, here, let me unlock this one. Okay. And then write a 3 to 5 page paper describing the use of Java in the first Intel version of the Solaris operating system by Sun Microsystems, now called Oracle. The paper should contain at the least topics related to performance, security, hardware compatibility, and user experience.
My brain is going to melt with all these people. Okay.
Make sense?
Yes.
Sometimes we can write the same concepts in 1 or 2 pages. That's fine if we write the same concepts that you want, or the points that you want to cover.
Well, you can try.
I can cover it in 1 page or 2.
You could try to cover it in 1 page, but if you don't give me enough detail, you'll lose points.
So the important is to cover the points or to give 3 to 5 pages.
Yes.
Yeah, the last assignment, I feel like I did everything in about a page and a half.
Well, we'll find out.
Everything. I compared Java with C#, with everything that you want.
Well, right. Did you go into all the detail you could have possibly gone into?
The important things.
Maybe all the important things you found.
Yeah.
Oh, Lord.
What
Don't make me nervous.
about the important things that you didn't find?
No.
Because
this
you were
is all
trying
I
to-
found. I mean, those things, I think that was important for me.
So,
Well, right, but it's what's important to me, isn't it?
I'm
how
not
do
sure
we know
about
what's...
you.
Oh, so what's important to you is what we go over in class. So, pretty much...
What's important to me is all the crap that you left out.
Thanks. Are we going to have reports every week?
Oh, yeah.
So we got to keep writing these 5-page papers?
Oh, they get longer. It gets ridiculous. At the end, they're 30 to 35 pages.
And we can do both.
But he'll do it in 1.
This is the first class you did this. Is that right?
This class has this format.
Why only us?
Well, no, not only you.
This is the first class. Is that right?
We recently got accredited as a stronger university, and now we have to have both a theory and applied portion to every homework assignment in our graduate programs.
Does that include every...
All of them from now on.
Wait, so when did this start?
It started any courses this fall.
Oh, okay. Because it... Okay. No, I'm not going to comment. Go ahead.
Because your other classes aren't doing it? Is that what you're saying?
Pretty much, but we not gonna
Supposed to be doing it. But I'm counting every word. You better hit at least 3 pages.
I did 5 pages.
5?
But
That's
I
just
don't-
fluff.
you know.
So you're sitting here telling me that you were done talking after a page and a half.
Yeah.
And you kept going to 5.
I can go.
So I gotta
But
read your garbage.
If I did a summary, I can do it in a page. But the other 4
You-
pages are
you
cover
might
page and reference.
I want to read good content. I don't want a page and a half of good crap followed by another 3.5 pages of fluff.
So
I want 3 pages of good crap. Give me some pictures or something. Draw me some diagrams.
well, I made you a cover page that looked pretty.
Does that count as one of your pages?
No, it actually doesn't. If I did, then it'd be 6 pages.
I mean, we can go more than 5. I mean,
Okay. No, stop it.
Okay,
What is
I mean,
wrong
just
with
like-
you?
As you said, like diagrams, pictures, stuff like that.
Okay, here's the punchline. All right, let me honestly give you the punchline as it relates to these papers.
Let's go through your syllabus.
Hold on. I am not going to count lines and stuff like that on these papers. Okay? Don't turn in a half a page thing for a 3 to 5 page paper. Show me you put some effort into it. If you do it in 2.75 pages, I'm not going to immediately start docking points as long as you had good stuff to say. If you roll into a 6th page because of diagrams or something, that's fine. I'm looking for your content. Well, actually, I'm looking for 2 things. I'm looking for your ability to explain complicated material in an easy-to-read format. Because keep in mind who your audience is going to be in IT. Your audience is not going to be people like me. It's going to be non-technical people. Okay? And specifically, in a group made up of a lot of people where English is not your first language, I'm looking for something that doesn't read like I'm talking to Dell customer support. Okay? I need to understand what you're saying. So, some of it's going to be take it to the writing center, take it to somebody else and have them read your paper. Make sure your paper doesn't sound like a 5-year-old wrote it. Make sense?
Yeah.
Okay? I mean, I get it. I mean, if I wrote a paper in Arabic or something, it's going to look way worse than a 5-year-old in Saudi Arabia would write. But that's why I'm here, not in Saudi Arabia. So rate me some legible crap, okay? So I'm not counting lines, but I want good content. If you really think you said what you needed to say in 2 pages, it's fine.
Okay. Is it double line? Double
Oh,
spaced.
no, double spaced.
Yeah.
You're double spacing?
No.
Yeah.
I didn't.
You didn't double space.
No.
Oh my god.
Hold up.
It's a lot
I
of
put
crap.
1.5.
Okay, so you did 1.5, and you gave me 5 pages of that?
Yes.
What font size?
12.
We gave you a 4. I wanted to be thorough. I'm sure it's just fine.
So, do you have all of these specifications outlined in your syllabus? Because,
What specification?
oh Lord, the ones that you just went over about how you want your papers.
No, there's no real specification.
That sounded like.
Self-space.
Well,
Huh?
no, I ain't talking about.
I really
the
don't care
font.
about this stuff. I mean, just answer the questions and make it look like a 5-year-old didn't write it. I don't care about bibliographies. I don't care about referencing stuff. This is not the stuff I'm interested in. Some of the other teachers might be interested in that kind of stuff. I'm interested in your ability to express words to non-technical people.
Gotcha.
Okay? I mean, yeah, I don't plagiarize off each other because then you're just cheating yourself. If you want to copy something out of Wikipedia and then elaborate on it, I'm fine with that. Because keep in mind, when I'm reading your paper, I'm gonna pretend like I'm somebody who's non-technical that you gave this document to explain something. That's the audience that I'm going to be reading it as. Okay? So, I mean, I really don't care about a bibliography or any of that crap. I know you guys just make them up anyways. You just grab a bunch of resources, put it on the back page, comma delimiter, says, yeah, I used all this. use all that crap. Give me a break.
What is the cutoff time to submit the assignment?
Before next class.
6.
Okay, 6 p.m.
So 5.
Yeah. Yeah, 5. We just before next class.
Sorry, sir. Yeah, program will be same. Like everyone uses the same logic to execute the program. So is everyone will be.
Oh, you mean the Hello World program?
Yeah. Hello world program. The program which you today. So like everyone.
You'll be fine.
Oh wait, were we supposed to actually submit the?
You're concerned that your Hello World program will look like everybody else's Hello World program is what you're saying?
Oh wait, question.
Not my first rodeo. I'm certain there's only so many ways you can write a Hello World program. You'll be just fine. And you probably all copied it from the same Google source anyways.
Specific, loops or operator, or just we can search in the Google and we can find some solution.
What do you mean for this assignment?
Yeah.
I would say the blanket statement is this. Any assignment I give, I'm asking you to solve it in terms of what we have covered in class. So to solve this particular problem, the programming question, you only should use things that we've explained in class.
Modulus.
So you'll need modulus, you'll need a loop, and you'll need if statements.
And
Any loop.
I don't care what loop you use. I mean, logic should say that you should use the loop that makes the most sense. But if you use a while loop instead of a for loop or something, I'm not going to take points off. I care more about your logic and your correctness because, like I said, you can solve any problem that requires looping using any of the loops. This particular problem lends itself to a for loop because you're going through all the numbers between 1 and 1,000,000. You know how many numbers you have to spin through. But if you want to write it as a while loop, it's not like it's horrifically wrong. It's fine. So pick your loop as far as I'm concerned. Okay?
question. Dang it, now I almost forgot. Oh, were we supposed to submit Hello World or just the tutorial that we wrote?
The tutorial's fine.
Oh, okay, good.
Yeah.
And another question. Can you activate the syllabus while you're in there?
Yeah, oh, it's not in there. Didn't I just look?
No.
All right.
You look for your report.
Oh. Right.
About the homework, we should upload the code and the output together.
It just whatever it tells you to upload. The important thing. Well, hold on, everybody relax. I don't see the syllabus in there.
Shouldn't it be under like resources?
You would think. Think I wrote this thing? I wrote up all the content and gave it to some dude who writes the courses.
Oh.
I'll find it. I'll put it up there.
Can you please upload the PowerPoint?
Upload the PowerPoint.
Yes.
It's killing me. All right.
Oh, and your pictures of your crazy
Or
cats.
send it to me on Facebook.
All right. Well, shoot me an email asking for the PowerPoint. I'll have to pull it off iCloud.
Send you on Facebook.
Well, if you give me an email, I can reply to it with the PowerPoint. So you can Facebook me, then I'll reply back and say, send me an email. Then if you send me an email, I will reply back with the PowerPoint. All right. Yeah, I'll put the syllabus up.
Okay.
If you don't see it up by like tomorrow afternoon, email me, and I have it. It's around.
Somewhere.
What was I doing? We're good. All right, and I'll unlink these two videos as soon as I get the right links in there for them because they're last semester's links. All right, let me make sure I did 8 unchecked access.
I think you did it, yeah.
Okay. All right, we're good. I'll see everybody at 6 p.m. next week.